That was good delivery. I like that. All right, so we're talking about quality control today. I heard a number of earlier presenters mention data quality and data quality issues. A little company called Esri gave me this quote: "Data quality is one of the most overlooked aspects of managing a GIS." I wholeheartedly agree. There's nothing worse than, as a consultant, delivering a nice data package to your client only to have it thrown to the wolves and destroyed, through various data manipulation and, for lack of a better word, lack of tools to maintain the integrity of that data. So this is a little bit of a project background, and actually Robert and I are living on the edge today. We're going to do a live software demonstration, so you can, I know, it's like bad idea, right? But you can't really appreciate it until you see it. So, in 2008, National Fuel Gas decided to go through a very large data conversion project. They hired an offshore company to convert their 6,000 utility record drawings and many various disparate databases and age records and design files into a central geodatabase for gas distribution. As part of that project, they developed a massive 300-page data conversion specification for that conversion vendor. And basically in that spec, it outlined the rigorous acceptance criteria for those deliverables. And I'm not going to go into detail with all of them, but things that were in that spec included, what percentage of the attributes had to be populated, how accurate was the content of those attributes, making sure that valid values or domains were applied, making sure that there was connectivity in the database, making sure any parent-child relationships that were modeled in the enterprise database were populated, and then assessing the positional accuracy of the line work and the features themselves. In total, there were 9 data deliveries to National Fuel, each of which composed of over 80 different object classes, so feature classes, tables, relationship classes. So we're talking about each delivery had literally thousands of records, thousands of attributes, so you're talking about thousands of data points. So when you talk about that amount of data, that much data, there's lots of rooms for error. So National Fuel was faced with a couple challenges. Number one, how could they ensure that the data that they were getting delivered was meeting their specification? And number two, how are they going to automate or streamline their quality control processes? So they're getting all this great data back. Hopefully it's great data, right? And then how are they reviewing it? And they have a GIS team, but not unlimited resources, and more importantly, not unlimited time to complete the project. So manual data review, not possible with all that amount of data. It's too limited and too slow. And most importantly, the executive said extending the conversion schedule for the project is not possible because time is money, right? So they decided to retain Bergmann to configure and implement a piece of software called ArcGIS Data Reviewer. Has anyone here heard of the software or used it before? All right, that's great. Excellent. So basically what we were hired to do is, number one, configure over 300 different data validation checks. Develop these as batch jobs, which could be run. Install the software at National Fuel and against the vendor deliverables from the offshore company. Test the data checks to make sure that, number one, the checks were configured properly. Number two, that there weren't any data model errors, or there weren't any errors in their spec. So obviously you could have errors coming not only from the data conversion itself, but if you didn't set up those checks properly, that could also introduce errors. And then lastly, train National Field Gas on how to use data reviewer to perform the quality control themselves. So 3 really parts of our project. One, just a quick review or a quick overview of what GIS Data Reviewer is. And then Robert's going to do a software demonstration, and then we're going to talk about the successes. So basically, Data Reviewer is a way to determine the health of your data and organize those results efficiently and accurately. So what is it? It's an extension to ArcMap and ArcCatalog, and not at 10.1 there's now a server extension available. Used for quality control to ensure data integrity. And 2 kind of big pieces, there's tools for automated review, which is basically once you've set up your checks, you press a button, run those checks. And then also tools for doing visual review, so looking at the data manually, but in an organized fashion. And then many tools for error correction, so if you wanted to implement this in a production environment and keep track of errors and then correcting those errors, tracking and reporting, there's tools for that as well. So what type of checks can you run with Data Reviewer? I can't remember how many default checks there are available, but I think there's upwards of 50 different types of checks. So spatial checks, looking for bad geometry, looking for duplicate geometry, gaps, slivers, holes. I'm sure none of you have come across these type of data issues before. Attribute checks, so running any type of SQL queries. Format, if you have your values are supposed to be formatted a certain way, you can check for that. You can compare tables, and if there's supposed to be relationships between tables, you can check to make sure those relationships are there. For those of you that know a lot about databases, there's you can run checks for domains or valid values to make sure subtypes were created, relationships, metadata checks, and some of the newer checks. Now you can actually take 2 different databases that are supposed to be identical and run checks to see if there's any adds or modifies or deletes between those 2 databases, so you can compare those. So we don't have a ton of time, but there's sort of the main components of Data Reviewer. You have your data, you have your data rules, what they call a reviewer workspace, a reviewer session, and a reviewer table. Essentially, you configure your data rules, which National Field did the hard work. Their engineers and their IT people sat down and came up with all these rules for their data, gave them to me in spreadsheets, and then I configured them in the software as what are called batch jobs. So the batch jobs are configured against their deliverable GIS database. That's fed into the software, and then the software outputs the results from those data checks. And those results are stored in what's called the reviewer table. And then you can interact with those results through what are called reviewer sessions. So basically, National Field had kind of like a 2-phase workflow with their quality control. The first was automated review, where they would essentially go through this process. Robert would run the checks, and then he would review the results, and then based on their acceptance criteria, the data would either pass or fail. If it passed, it would go on to the next phase. If it failed, data was returned to the conversion vendor. So if it passed, it went to the second phase, which is the manual visual review, which basically National Field staff would create a sample set, which you can do through the software, and then they would review that sample set, which was based on a military spec, which is noted here. So they're sampling a statistical significant sample for based on the size of their deliverable. Again, do their visual review, get the results, and then if it passed, they would accept their deliverable. If it failed, again, they would return that deliverable to the vendor, and then again go through the same process. All right. Now, Robert.
Right. Good luck, Robert.
I'll need it.
I should preface this by saying I had no experience using PLTS before. Kate was lucky enough to train us before we started using it. And if I can do it, you can do it. It's very simple to use. So let's take a look. This is just a small snippet of our GIS pipeline data. This is in the town of Corey in Erie County. Normally we would start by opening the PLTS toolbar, which we have here, and starting the session. Hopefully this will work. All right. Oh boy. So as you can see here, we have a collection of sessions. You do have the option, if you don't have many checks to run, of only running one session. We had multiple users doing checks, so we each had individual sessions to go and review. So I have one just for us today, demonstration here. Start that. So now what I'll do is I'll open up the series of checks and we can review them. So this is a list of all the checks we're going to run. We have some constraint checks based on year was booked, year the pipe was booked, the material of the pipe. Certain materials can only have certain pressure types, maximum pressure, things like that. So this is very, very useful instead of going through each feature and chugging through the attribute table, sorting it, looking for errors. This is basically a one-stop shop. So first I'm just going to make sure our workspace is set up properly. And you can see we have check marks, which is always a good thing. Hold on, before I congratulate myself here, I'm going to go over it now. Looking good. Okay. Now I don't want to see that. So next, you have the option of running checks on the current extent here. We always do the full database, so we'll do that again. Make it best suffer. Add the checks here. And then let it run. Now hopefully this should only take about 10 seconds. It's working its magic. Now we have some errors, so that's both good and bad. No records written to. Okay, that's okay. They're already sitting there. So next, we can open up our review table here, and this will show us all the items that were written to the table. So these are all errors, or what we have defined as errors in our SQL checks. And what's nice about this is that it's very easy to organize. All you have to do is go to our check description field, which is in our notes, drag this up, and it will categorize all the errors by the different check types. So you can see we have plastic that was supposedly installed before 1969. That's not right. And some other errors here. Shape length error. We had a constraint of the actual shape length of the line could not be greater or less than 15% of the actual user-defined measure of a pipe installed. So say we install 1,000 feet, the shape is 5,000 feet, we need to go take a look at that. And the easiest way to do that is just to take this and kick it out in an Excel spreadsheet and do a little analysis. I like to kick it out and create a new field showing the difference between the two. And it's easy to go back to the feature by object ID. But you can also navigate through this table. I'll show you that. So you just have to click on the field, or on the row, excuse me. It takes you right to that feature. Again, normally I have double screens too, so I want to have this on the other side because it gets a little cumbersome trying to see, well, what's wrong here. So you can go to each feature, and it'll select it. You can review it. Once you're done with your review, you would just simply right-click on the record, enter your correction status. That's basically your notes back to the vendor. So you can say, oh, this is good, shouldn't have been an error. Or you could say you're terrible, you didn't follow the rules. You can type in your own comment. Oh my God, I can't believe you did that. And that will save, hopefully, there we go, to the table. I'm getting a text message. There we go. So, oh my God, I can't believe you did that. You'll kick that out, send it back to the vendor. They'll see that, like, oh, we need to look at this. And you'll have a collection for each session that you have. So you can basically go through each record, review it, put in your comments, export it, send it back. Saved us a lot of time. That made the executives very happy. Once you're done with your comments, just go ahead and end your session. Everything is saved. And that's basically it in a nutshell.